Welcome to GATE class. So let us see this problem. The Fourier transform of a signal. The Fourier transform of a signal Ht is h omega, and that is equals to 2 cos omega sine 2 omega divided by omega. The value of h0 is, so we need to find out the value of h0. So this ht is given as minus infinity to plus infinity hf e raised to the power minus j omega t into dt. This is ht, and hf is given as minus infinity to plus infinity ht. This is gdf e raised to the power minus j omega t into dt. So this is the Fourier transform pair. So let us solve this problem. Let us find out solution of this problem. So to this ht is given as, this Fourier transform is given as, the Fourier transform of ht is given as, that is equals to h omega, it is equals to cos omega, 2 cos omega sine 2 omega divided by omega. So this hs can be written as 2 cos omega sine 2 omega divided by 2 omega, and it is basically if we multiply here, then it is 4 cos omega sine 2 omega divided by 2 omega. This is h omega. So this is basically we can just write it as 1 by 2 e raised to the power j omega plus 1 by 2 e raised to the power minus j omega multiplied by sine 2 omega divided by 2 omega. So let us concentrate on this term, that is, this is h1 omega. So let h1 omega is equals to sine 2 omega divided by 2 omega. And these factors are basically, they are just providing the shifting. These factors, basically these two factors, they are providing the shifting in time domain. They are providing the shifting in time domain. So basically if we find out ht, if we find out ht, then it is simply, if we just if we find out ht, what is simply, it is simply 2 times h1 t minus 1 plus 2 times simply h1 t plus 1. And what is h1t? h1t is Fourier transform of h1 omega. Just we have used that property that if gt has Fourier transform gf, then gt minus t naught has Fourier transform e raised to the power minus j 2 pi f t naught into gf. And if we write in terms of omega, then if gt has Fourier transform g omega, then gt minus t naught has Fourier transform e raised to the power minus j omega t naught into g omega. This is simply the expression we have written. This is simply the expression we have written. So it is simply, we have just if we find out the Fourier transform of this, inverse Fourier transform of this, that is h1t, then it is that factor multiplied by this is basically we just find out this value, then we find out that T naught is basically 1 here, so it is Ht, we can write it as 2 times H1T minus 1 plus 2 times H1T plus 1. It is simply that. Now if now our main task is to find out the value of H1T, because if we want to, if we are able to calculate the value of H1T, then we are easily calculate the value of HT. So what is our aim? So we need to calculate the value of H1T. So H1T is basically the inverse Fourier transform of H1W, or Fourier inverse of H1W is equals to H1T. So we need to calculate this. So let us solve this problem. So we need to find out H1T, that is Fourier inverse of H1 omega, and H1 omega is equals to sine 2 omega divided by 2 omega. This is H1 omega. Now what we are going to find out, we have relation, that relation is 2a sine a omega divided by a omega. The inverse Fourier transform, is simply a pulse. The inverse Fourier transform is simply a pulse from minus a to plus a. That pulse has value 1.0. So this is the inverse Fourier transform. Now we have sine 2 omega divided by 2 omega. So here we have we can just see that this a is equals to 2. So this a is equals to 2. So what we are going to find out here, we have a is equals to 2 here. So what we will get here, if we just compare it with if we just compare it with, then what we will get, a is equals to 2. So this is the pulse, this is basically the pulse we are getting, and the pulse has that amplitude of the pulse is basically 1 by 2. This is the amplitude, that is 1 by 2, and it is from minus 2 to plus 2. This is the pulse amplitude. Now this is H1T. This is H1T. Now what is HT? So HT is equals to H1T minus 1 plus H1T plus 1. So H1T minus 1 is, this is H1T minus 1, this is minus 1, and this is 3, and the amplitude is 1 by 2. So this is H1T minus 1. Then we have H1T plus 1. So H1T plus 1 is, we have 1 and we have minus 3. Now if we combine these two, so what we will get, from minus 3 to minus 1, the amplitude is half, and here from 3 to 1, the amplitude is half, and from minus 1 to 1, the amplitude is 1. So this is HT. This is HT. Now H0 is equals to 1. It is clearly seen that the H0 is equals to 1. Let's do another problem. A signal a signal xt is determined by xt is equals to 1 for -1 to less than or equal to 2. So between -1 to 1 this xt is 1. So the value of xt is 1 between -1 to +1, and it is 0 otherwise. So two of the angular frequencies where Fourier transform become 0 are
बढ़िया है। पापा का नंबर लो, हमने मोबाइल के
pi 2 pi 0 pi 1.5 1.5 it is 0.5 pi 1.5 pi 0 comma pi 2 pi comma 2.5 pi. So let us find out the solution of this problem. So x omega is equals to -infinity to +infinity xt e raised to the power minus j omega t into dt, that is equals to -1 to +1. Between -1 to 1 this xt is 1. So it is equals to e raised to the power minus j omega t divided by minus j omega from -1 to +1. So the solution of this problem is e raised to the power j omega divided by j omega minus e raised to the power minus j omega divided by j omega, and that is equals to e raised to the power minus j omega divided by j omega. So what we can see here that since Fourier transform is 0, so since Fourier transform since Fourier transform is 0, so e raised to the power j omega minus e raised to the power minus j omega is equals to 0. So it means e raised to the power j omega is equals to e raised to the power minus j omega, and that is equals to 2 e raised to the power 2 j omega equals to 0, and it is equals to 0 when we have the condition that omega is equals to m pi. So it is 0, pi, 2 pi, 3 pi. So all these values, this omega, this value is 0. So the Fourier transform is 0. So our answer is basically that 0 and pi. These two frequencies. On these two frequencies, the Fourier transform will become equal to 0. So the answer is 0 comma pi. So let us solve another problem. The 3 dB bandwidth of low pass signal e raised to the power minus t into ut, where ut is the unit step signal, ut is the unit step signal, is given by, find out the 3 dB bandwidth of the this signal, low pass signal. So est is given, that is equals to e raised to the power minus t into ut. Hf is given as 1 divided by 1 plus j omega. Now modulus of Hf is equals to 1 divided by under root of 1 plus 4 pi square f square, and that is equals to 1 divided by root 2. So when we have solved this, so the solution is 1 divided by 2 pi hertz. Please check this answer. So this f is equals to 1 divided by 2 pi hertz. Please check this answer. So let us solve another problem. The output yt of a linear time invariant system is related to the input ext by the equation yt is equals to 0.50x t minus td plus capital T plus x t minus td plus 0.50 x t minus td plus capital T. The filter transfer function of the system is given by so we have yt, that is equals to 0.50 x t minus td plus capital T plus x t minus td plus 0.50 x t minus td plus capital T. So let us take the Fourier transform on both sides. So taking the Fourier transform on both sides, we get yf is equals to 0.50 e raised to the power minus j 2 pi f td minus t into xf plus exf multiplied by e raised to the power minus j 2 pi f td plus 0.50 xf e raised to the power minus j 2 pi f td minus capital T. So yf is equals to 0.50 e raised to the power minus j 2 pi f td plus multiplied by e raised to the power j 2 pi ft multiplied by xf plus e raised to the power minus j 2 pi ftd multiplied by xf plus 0.50 e raised to the power minus j 2 pi ftd e raised to the power plus j 2 pi ft multiplied by xf. So what we are getting finally is hf, that is equals to yf divided by xf. Please check this relation. So that relation is e raised to the power minus j 2 pi ftd 0.50 e raised to the power j 2 pi ft plus 1 plus 0.50 e raised to the power j 2 pi ft. So hf is equals to e raised to the power minus j 2 pi ftd 1 plus e raised to the power j 2 pi ft, and this hf is equals to e raised to the power minus j omega td 1 plus e raised to the power plus j omega t. So this is final relation. So this is transfer function. This is transfer function. So a signal, for a signal xt, problem is for a signal xt, the Fourier transform is xf. The Fourier transform is xf. Then the inverse Fourier transform, x 3f plus 2 is given by so the signal is that xt has Fourier transform, that is xf. Now if x is equals to 3x plus 2, so we need to find out the inverse Fourier transform. This inverse Fourier transform we need to find out. So let us solve this problem. So this problem can be solved directly by using either integration, or also we can apply that shifting and all these things. So let us do first method. Let us do by integration. So first method, so let x1t is Fourier inverse of ex 3f plus 2. Let x1t is Fourier inverse of x 3f plus 2, and that is equals to minus infinity to plus infinity x 3f plus 2 e raised to the power j 2 pi ft into df. So let us take 3f plus 2 is equals to k. Let us take 3f plus 2 is equals to k, and f is equals to k minus 2 divided by 3. So df is equals to dk divided by 3. So dk is equals to df divided by 3. So this is first equation. So what we are going to observe is minus infinity to plus infinity xk, this 3f plus 2 is replaced by k e raised to the power j 2 pi f k minus 2 divided by 3. Instead of t we are just instead of f, and this df is dk divided by 3. So this x1t is equals to minus infinity to plus infinity xk e raised to the power j 2 pi tk divided by 3 e raised to the power minus j 2 pi t into 2 divided by 3 dk. So it is 1 divided by 3 minus infinity to plus infinity xk e raised to the power j 2 pi t divided by 3k into dk, and this e raised to the power minus j 4 pi t divided by 3 we can put outside. This we can put outside. So what we are getting finally is 1 by 3 e raised to the power minus j 4 pi t divided by 3 into x t divided by 3. This is our solution. This is our solution. So x 3x plus 2, the Fourier inverse of x 3x plus 2 is equals to 1 by 3 x t by 3 e raised to the power minus j 4 pi t divided by 3. This is the final solution. Now we can solve this problem by using the second method also. So we are using second method. So xt has Fourier transform that is equals to xf. xt minus t naught has Fourier transform that is equals to if we just see that what is the Fourier transform of this xt minus t naught, it is equals to e raised to the power minus j 2 pi f t naught into xf. And if we are this is basically this property is telling about the delay in time, but here we have delay because we need to find out 3s plus 2. So here we have some delay as well as scaling, so it is written as 3f plus 2 by 3. So there is some delay, after that we have some scaling also. So how to solve this problem? So we can use we can apply the property here. So let us first solve this. Let us first find out. So first find out Fourier inverse of x f plus 2 by 3. Let us first find out Fourier inverse of x f plus 2 by 3. So Fourier inverse of x plus 2 by 3 is equals to xt e raised to the power minus j 4 pi t divided by 3. Now we can see that what is the scaling property. So xat is equals to 1 divided by modulus of a x f by a. This is scaling property. So here is scaling variable is 1 by 3. Please check this. The scaling variable is 1 by 3 because f by a. So a is 1 by 3. Now here is scaling. If we do scaling, then f inverse of x3 f plus 2 by 3 is equals to 1 divided by 3 x 1 divided by 3 t e raised to the power minus j 4 pi t divided by 3. This is our final answer. And this answer is exactly matches with the first method. So this answer exactly matches with the first answer that we got. That answer we got from by using the first method. This is same as first method. Same as first method. So let us find out the Fourier transform. So let xt and yt, let xt and yt with Fourier transform xf and yf with Fourier transform xf and yf respectively. So this is xt. This is xt and this is yt. So what we are going to find out the relation between yf and xf. Find out the relation between yf and xf. We need to find out the relation between yf and xf. So let us solve this problem. So this is xt. So this is xt. Now if we just see that yt, then what we have observed that if we do scaling in xt, after that if we shift the xt, and after that if we take the reverse time reversal across the x-axis, then we can obtain the yt. So let us discuss this step by step. So step 1. So in the first step we are going to perform the scaling of our signal, that is this signal is from -2 to 2, the amplitude is 1. So scaling, let us do the scaling, and we are going to do x2t. So x2t will scale it to -1 to 0 to +1, because this will gives the time compression. Basically the signal is compressed. Basically the signal is time compressed. Then in step 2, we are going to do the time shifting. So we have the signal that is x2t, and the signal is like this. This is our signal. So this is -1 to +1, that is x2t. So what we are going to do next, we are going to do the time shifting by one unit in left hand side. So this is ex2t plus 1 will gives us this will +1 and this will become -2. So -1, this is 0 and this is -1. So we have shifted to one unit in left hand side, with this +1 will become 0, this -1 will become, and the amplitude will remain same. So we did time shifting. In the last step, that is step 3, what we are going to do, we are going to do the reversal, that is -x2t plus 1. So what we are getting here, -1 0 -1. So ultimately yt is equals to -x2t plus 1. So this is yt. So what is yf? So yf is equals to -1 divided by 2 x f divided by 2 e raised to the power j 2 pi f. So this is our final answers. So this yf, we can find out this yf. Just we have xt, then we have x2t. So this xt has Fourier transform xf, xt has Fourier transform xf, x2t has Fourier transform 1 divided by modulus 2 xf by 2. Then if we shift it, then x2t plus 1, the Fourier transform is 1 by 2 xf by 2 e raised to the power j 2 pi f, because shifting is in one unit. And when we have minus x2t plus 1, then only minus sign will appear. So this is the Fourier transform. So yf is equals to -1 by 2 xf by 2 e raised to the power j 2 pi f. This is the Fourier transform. Let hf denote the frequency response of the RC low pass filter, Let f1 be the highest frequency Let f1 be the highest frequency such that 0 is less than or equal to f, modulus of f is less than or equal to f1, and modulus of hf1 divided by modulus of h0 is greater than or equal to 0.95, then f1 in hertz is, let us find the f1 in hertz. Let us find the f1 in hertz. So the RC filter is, we have R, then we have C, this is VI, this is V0. So this filter is RC filter. So we can find out the transfer function of this filter, that is HF, that is V0F divided by VIF, and it is equals to simply 1 divided by 1 plus J 2 pi FRC. It's very simple to calculate. So what we are going to find out, we are find out the magnitude of HF, and also we have H0, that is at F equals to 0, H0 is equals to 1, and modulus of HF is equals to 1 divided by under root 1 plus 4 square pi square F square R square C square. So what we are going to find out here, that modulus of HF divided by H0 is equals to 1 divided by under root 1 plus 4 square pi square F square R square C square, and that is equals to greater than or equal to 0.95. So squaring both sides will gives us 1 plus 4 pi square F square R square C square is greater than or equal to 0.95 square. So what we are getting finally is that F maximum, that maximum value is 52.2 Hertz. The maximum value is, F maximum is 52.2 Hertz. So this is the maximum frequency for this condition to be true. Let us do another problem. Let us do another problem. A periodic signal GT is shown below. GT is shown below. So GT is given. Let us draw this signal. So it is from minus pi by 2 to plus pi by 2 is 1. Then we have, it is periodic, so it is repeating after 2 pi. It is repeating after 2 pi. So find out the power spectral density. Find out the power spectral density of the signal. Find out the power spectral density. So The power spectral density is denoted, so this is power spectral density XFF. XXF is equal to summation n is equal to minus infinity to plus infinity modulus of Cn square. And what is Cn? Cn is simply the complex exponential Fourier series coefficient. So Cn is basically complex exponential Fourier series. Cn is simply the complex exponential Fourier series coefficient. So that gt can be written as, since gt is a periodic signal, so it is written as n is equal to minus infinity to plus infinity Cn e raised to the power j 2 pi n f naught. So what is Cn? Cn is equal to 1 divided by t naught 0 to t naught gt e raised to the power minus j 2 pi n f naught t into dt. This is Cn. So if we calculate, we will find out that it is 1 divided by 2 pi minus pi by 2 to plus pi by 2, it is equals to 1, then minus j 2 pi n. What is f naught? F naught equals to 1 divided by 2 pi, so it is 2 pi t dt. So the solution of this is 1 divided by 2 pi e raised to the power, if we solve this, then we will get minus j 2 pi n e raised to the power minus j n pi divided by 2 minus e raised to the power minus j en pi divided by 2 plus this is plus. So finally we are getting sine n pi divided by 2 n pi divided by 2. So this is the solution we are getting, and it is equal to 1 by 2 sinc n by 2. So what we are getting here, that Cn we are getting is sine n pi divided by 2 pi n divided by 2, and that is simply, since sinc x is equal to sine pi x divided by pi x, so it is equal to 1 divided by 2 sinc n divided by 2. Now what we are going to find out, the various values of the complex Fourier coefficient. So for n is equal to 0, that C0 is equal to, if we calculate that C0 is equal to 1 by 2, because C0 is simply the average value. So C0 is equal to 1 by 2, because sinc 0 is 1, because sinc 0 is equal to 1. So sinc 0 is equal to 1, so 1 by 2 multiplied by 1 is 1 by 2. So C naught is 1 by 2. C1 is, when we have n is equal to 1, so C1 is 1 by pi. C minus 1 is equal to, if we calculate, it is 1 divided by pi. C2 is equal to 0. C minus 2 is equal to 0. C3 is equal to minus 1 divided by pi. C minus 3 is equal to minus 1 divided by pi. So if we summarize this, then what we are getting is Cn is equals to 0 for n is equals to plus minus 2 plus minus 4, n is equals to plus minus 2 plus minus 4 plus minus 6, and Cn is equals to 1 divided by n pi for n is equals to plus minus 1 plus minus 5 plus minus 9, and Cn is equals to minus 1 divided by n pi for n is equals to plus minus 3 plus minus 7 plus minus 11. So for all these values it is equals to minus 1 divided by n pi. So that xf is equals to summation n is equals to minus infinity to n is equals to plus infinity modulus of Cn whole square, that is equals to n is equals to minus infinity to plus infinity modulus of 1 by 2 sinc n by 2 whole square. So it is equals to summation n is equals to minus infinity to plus infinity 1 by 2 sinc n by 2 whole square. So this is xf, this is xf, that is power spectral density. So this is the power spectral density. Let us solve another problem. Find out the Fourier transform of the following signal. So the Fourier transform g omega of the signal gt given in figure 1, so this is figure 1, this is gt, this is 0, this is minus 1, this is plus 1. So given in figure 1 is GW, that is Fourier transform, is equals to 1 divided by omega square e raised to the power j omega minus j omega e raised to the power j omega minus 1. This is the formula. This is the Fourier transform for this signal GT. Now using the concept of time shifting, time scaling, determine the Fourier transform of signal given in figure 2, 3 and 4. So figure 2 and 3 and 4 is shown here. So this is figure 2. So this is G1T and this is given as This is G1t, so it is 0, this is plus 1. Then figure 2, then figure 3. Figure 3, this is Z2t. It is 1, 0, minus 1. Figure 4, that is G3t. So these three figures are given. Now find out the G1f. So find out G1f, G2f and G3f in terms of GF or G omega, because G omega is given, so better to take G omega. So this is G1 omega, G2 omega, G3 omega in terms of G omega. We need to find out. So let us solve this problem. First we have to establish relation between the G1t, G2t and GT with GT. So G omega is provided in the question, that G omega is equals to 1 divided by omega square e raised to the power j omega minus j omega e raised to the power j omega minus 1. So this is provided. Now what is G1t? So if we carefully observe that G1t, so G1t is what we are getting is G of minus t, because this is GT, this is GT, this is GT. So G of minus t is just mirror image of this. So the mirror image is just like this. So this is G of minus t and this G1t is equal to G of minus t. So what is G1 omega? G1 omega is G of minus omega, and G of minus omega is 1 divided by minus omega square. From this equation, e raised to the power minus j omega minus will become plus e raised to the power minus j omega minus 1. So it is 1 divided by omega square e raised to the power minus j omega plus j omega e raised to the power minus j omega minus 1. So this is G1 omega. This is G1 omega. Now let us find out that G2. Let us find out the G2t. Let us find out G2t. So G2t, just if we write G2t, so what is G2t? G2t is simply the relation between G2t and G1t is G2t is simply G minus t minus 1. Let us check this relation. So this is GT, this is GT, so what we will get GT minus 1. So GT minus 1 will provide us this equation. This is GT minus 1, and the time reversal will gives us this equation, and that is G minus T minus 1 is equal to G2T. This is the graph. This is the graph of G2T. This is the graph of G2T. Now G2t is equals to G minus T minus 1. So what we can find out here that this G2t is equals to G minus T minus 1. So just we perform that scaling. So G2F is equals to, here we have this shifting and time reversal. So what we are getting here, we are getting GF multiplied by e raised to the power minus j 2 pi f. Please check this relation. Please check this relation. So in terms of here we have minus f. Here we have minus f. So G2t is G minus T minus 1, and the Fourier transform is equals to G2f is equals to G minus f e raised to the power j 2 pi f, and in terms of Fourier transform we can write it as G2 omega is equals to G minus omega e raised to the power plus j omega, omega is equals to 2 pi f. So putting the value of G minus omega, that is simply derived from G omega. So what we will get here, so we will get G omega is equals to 1 divided by omega square e raised to the power j omega minus, so so this is G2 omega, that is equals to 1 divided by omega square 1 plus j omega minus e raised to the power j omega. Now let us derive, so let us derive G3t. So how we will get G3t? So this is Gt minus 1 by 2. So Gt is basically, what is Gt? So Gt is, this is Gt. So from 0 to minus 1, the amplitude is plus 1. So if we shift it to right hand side by half unit, then it will become Gt minus 1 by 2. And what is G1t? So G1t is simply, this is G1t, this is G1t. If we shift this signal to halves, means if we find out G1t plus means basically this is G1, this is G1t plus 1 by 2. So this is G1t plus 1 by 2. So what is G1t basically? So G1t is simply, we have this, it is given in the question itself. This is G1t. So this is G1t. This is 0. This is plus 1. This is amplitude plus 1. So this is G1t. Now if we shift this in left hand side half unit, this will become G1t plus 1 by 2. So we have shifted this to left hand side by half unit. So this is G1t plus 1 by 2. Now if we add G1t plus 1 by 2, this is G1. If we add G minus 1 by 2 plus G1t plus 1 by 2, what we will get? We will get G3t. So G3t is simply G t minus 1 by 2 plus G1 t plus 1 by 2. So that result is we have G omega e raised to the power j omega t by 2, and here we have G1 omega e raised to the power minus j omega t by 2. So what we will get finally, we are putting the value of G omega. So G omega is it is given in question. So g omega is equals to 1 divided by omega square e raised to the power j omega minus j omega e raised to the power j omega minus 1 e raised to the power j omega t by 2 plus this is g3 omega, and this g1 omega is equals to what we are getting, g1 omega. So g1 omega is equals to we have derived this is 1 divided by omega square e raised to the power minus j omega plus j omega e raised to the power minus j omega minus 1 e raised to the power j omega t by 2 minus j omega t by 2. So this is g3 omega. This is g3 omega.